Welcome, geometry, and happy Monday. We have so far talked about several transformations. We've talked about translation, which just means to move. We talked about rotation, which is to rotate around a center point to turn. Now we're going to talk about reflections, which is just like a flip. So 5.3 learning target is I can reflect figures in a plane. And success criteria, you'll be successful when we can discuss writing a definition of reflection as a function and also understanding that it preserves measures of segments and angles. And I have a funny little meme down there. All right, let's get started. Some vocabulary just to get us started off here. A reflection is a transformation across a line of reflection. So in order to do a reflection, you have to have a line of reflection such that the line of reflection is the perpendicular bisector of each segment joining each point in its image. I would encourage you to get down the things that are underlined in blue at least. And let's discuss what this actually means. This is a very technical definition, so we're going to draw a picture of it as well. Let's say that I have point P, and I want to reflect point P across this line, line M. So I know P prime is going to be somewhere over here, right? And one thing we know about reflections is that they are the same distance away from the line of reflection. So if they're the same distance away, well, that means that I'm going to call this middle point D. That means that PD and P prime D is the same length. And we're also going to make sure that this is, according to the definition, the perpendicular bisector. So yeah, we see that the segment, this entire segment, P to P prime, is perpendicularly bisected by this line of reflection. And if we wanted to write this out in function notation or reflection notation, similar to the way we did translations, we have a big R, R for reflection. We're doing a reflection using the line of reflection M on point P. After that reflection using line M on point P, you get P prime. All right, so very similar to the way we did translations as well. Let's take this definition and look at an example here. Is line P, which I'm going to highlight right now in yellow, is line P right there the line of reflection for my triangle ABC, which I'll highlight again in yellow, ABC and A prime, B prime, C prime. We just talked about how if it's going to be the line of reflection, it's going to be the perpendicular bisector of the segment joining the 2 points that we're reflecting, right? So let's just take a look for an example. Let's look at, hang on, let's look at point A and A prime. So the segment joining A and A prime, it's here in the blue. And we see that right here, this point where line P intersects that segment, well, it intersects perpendicularly. We have that right angle there. And we have these little hash marks that show that that point of intersection is the midpoint. So definitely line P is the perpendicular bisector of segment A, A prime. So far, it's looking like line P is going to be the line of reflection, according to that definition that we just had. If we look at the other points, so let's, for example, look at point B and B prime. Again, we see the segment joining those points, that entire segment, it's bisected because we have those little hash marks, and it's bisected perpendicularly because we have that right angle there. Same thing with point C. Point C and C prime, it's being reflected. Again, we have that segment. It's being perpendicularly bisected by line P. So definitely line P is the line of reflection for ABC and A prime, B prime, C prime. Okay, we're going to get into some coordinate rules, but I do want to explore a GeoGebra file real quick. So we're going to start reflecting across the x-axis, the y-axis, and a couple other special lines. So let's just look at a reflection across the y-axis. You see here, the y-axis has that little dotted line, so we're going to assume that's our line of reflection. We have point B, which is at -9, -2. It's being reflected across, and we get B prime. And we see that B prime, its coordinates are +9, -2. So, again, the only thing that changed there was the x coordinate. Again, we see that the y coordinate is the same because it's on that same grid line of -2. But the only thing that changed was the x coordinate, which is now a +9 instead of a -9. If I refresh this again, check it out. Point B is at -2, 2. B prime is at +2, 2. B is at -4, -7. B prime is at +4, -7. So already we can kind of see this pattern of, well, the y isn't changing, but the only thing that's changing is we're making our x coordinate, we're just flipping its sign, we're making it negative. So that's a reflection across the y-axis. If we want to reflect across the x-axis, well, let's take a look. I've got that line of reflection, a dotted line horizontally through that x-axis there. And let's look at the points that we're given. We have point A, which is at 7, -9. And we have A prime, which is at 7, +9. So a reflection across the x-axis, all it's going to do is make your y coordinate positive. And we can even see that like visually too, right? I mean, A, the blue point down at the bottom, it's definitely where the y's are negative. After reflecting it, A prime is up in that area where the y's are positive. So already we can see that rule. Let's take a look at one more, if I can get there. All right, what about the line y equals x? So this line y equals x, it has a slope of 1. Its y-intercept is at 0. So it's a pretty simple line, just that nice diagonal. Let's take a look at the points. Point C is at -3, -6. C prime is at -6, -3. So looks like all I did was just flip the points around. I didn't have to make anything negative. All you did is just change the coordinates. Let's go back and look at our rules now, make sure those make sense. You may want to pause and get a sketch of this for your rules of reflection. If we, again, wanted to do a reflection across the x-axis, we see that we're taking a point, x, y, and all that we're doing is we are making the y coordinate negative. All right, and if you want, you could even sketch out, I'm going to sketch off to the side, these lines of reflection. So if we're doing a reflection across the x-axis, that line of reflection is this horizontal line. If we were doing a reflection across the y-axis, our line of reflection is going to be that vertical line on the y-axis. And again, we see that that rule takes a point xy and it goes to -xy. So all that changed was we flipped the sign of the x coordinate. The line y equals x, I'll draw that over here. There's our coordinate plane. The line y equals x is just this diagonal line. So if we were reflecting across that line, again, all you're doing is you're taking that point xy and it's going to go to yx. So again, all we see is they flipped around. We exchanged the x and the y coordinate. The line y equals -x, I'll sketch out down here. Y equals -x is going to be a line of reflection. It is still a negative, or excuse me, it's still a diagonal line there. We just have a negative slope. And what it's going to do, y equals -x, it's going to take a point xy. It's going to flip the coordinates and it's going to make both of them negative. So xy is going to go to negative y, comma, negative x. All right, let's take these rules real quick, and we are going to talk about reflecting some points. So if I wanted to reflect the point negative 2, 4 across the x-axis, again, you could write out your rule. For the x-axis, we're taking a point x comma y, and we're going to x comma negative y. So if I have the point negative 2, wow, I can't write today, negative 2, 4, all I'm going to do, I'm going to keep the x coordinate the same, and I'm just going to make the y coordinate negative. It's a positive 4, so it's just going to become a negative 4. So after reflecting across the x-axis, that new point is at negative 2, comma, negative 4. If we reflect across the y-axis, you can look back at your rule. What you're going to do is you're going to keep the y the same, but you're just going to change the x coordinate. You're going to make the x coordinate negative. So if it's already a negative 2, it's going to become a positive 2, comma, again, that y coordinate from the original point stays the same. If you were reflecting across the line y equals x, again, I'll just scroll back up here. Y equals x says just take your points and flip them around. So 4, comma, negative 2. And then if you're reflecting across the line y equals negative x, again, we had to flip the coordinates and make them negative. So after flipping, you would have 4, negative 2. And then making them both negative, just changing the sign, you have negative 4, comma, positive 2. Okay, we'll go over some more examples like this in class.